Two electric cars, same model year, same battery chemistry, same number of cells. After 200,000 miles, one battery is at 93% capacity. The other is dead. The difference isn't the cells. It's the software that manages them. And it's called the BMS. The battery management system is the most important component of your electric vehicle that nobody talks about. It's the brain, the bouncer, the diagnostician, the lifeline. Today we open it up. Last week on What Inside, we walked through the anatomy of the battery pack. Cells, modules, chemistry, structural design. But we kept coming back to one mystery. Why do identical batteries have wildly different lifespans? The answer is always the BMS. In this video, we're going to understand exactly what the battery management system does, why it's the single biggest difference between EV brands, and why two cars with the same lithium-ion cells can age completely differently depending on the software running inside them. Let's start with what the BMS actually is. Chapter 1. The hardware. The BMS is not one chip. It's a network of electronic boards distributed throughout the battery pack. In a typical design, you have a main BMS unit, often called the battery management controller, and a series of slave units. The slaves sit next to each module, or sometimes next to each individual cell. They measure voltage, temperature, and current. They report back to the main unit thousands of times per second. In a Tesla pack with around 8,000 cells, this means thousands of measurement points generating millions of data samples per minute. The BMS processes all of it in real time. And it's not just sensing. The BMS also controls. It can open and close contactors, the high voltage switches that connect or disconnect the pack from the rest of the car. It can throttle current draw. It can stop charging. It can refuse to let you start the car. If the BMS decides something is wrong, the car listens. Chapter 2. Cell balancing. Here's something most people don't realize. The cells in your battery pack are not identical. Manufacturing tolerances mean that some cells hold slightly more charge than others. Temperature gradients across the pack means some cells heat up faster. Position in the circuit means some cells get more current than others. Over time, these tiny differences compound. After thousands of charge cycles, some cells are at 100% state of charge, while others are at 95%. This is bad, because the pack as a whole can only charge until the highest cell is full, and only discharge until the lowest cell is empty. The weakest cell defines the capacity of the entire pack. The BMS fixes this through a process called cell balancing. There are two types. Passive balancing is the simple version. The BMS detects which cells are overcharged and burns off the excess energy as heat through small resistors. It's cheap and reliable, but it wastes energy. Active balancing is more sophisticated. The BMS actually moves charge from the high cells to the low cells using small power converters. No energy is wasted, but the hardware is more complex and expensive. Tesla uses passive balancing. BYD uses a mix. Some premium European OEMs are moving to active. This single design decision affects how long your battery will last by tens of thousands of miles. Chapter 3. State of charge estimation. Your dashboard shows 95% battery. How does the car actually know that? It seems simple. Just measure the voltage. But lithium-ion batteries are deceitful. A cell at 50% state of charge has almost the same voltage as one at 60%. The relationship between voltage and remaining energy is nonlinear, depends on temperature, and changes as the battery ages. So the BMS uses a combination of techniques. Coulomb counting tracks every electron going in and out. Open circuit voltage analysis runs when the car is parked. Kalman filters predict future behavior. Some advanced systems use neural networks trained on millions of miles of fleet data. When you read that Tesla can predict your remaining range with 99% accuracy and a cheap EV is off by 20%, this is why. The BMS algorithms are wildly different. This also explains why your range estimate is wrong on cold days. The BMS is doing its best, but it's working with a battery whose chemistry is literally moving slower in the cold. Chapter 4. Thermal Management Coordination. The BMS doesn't just monitor temperature. It commands the cooling system. When the pack is hot, the BMS tells the coolant pump to speed up, opens valves to route refrigerant directly to the cells, and reduces the maximum charging rate. When the pack is cold, the BMS asks for heat from the cabin system, delays fast charging until the pack warms up, and limits regenerative braking. This is why your Tesla preconditions the battery before a supercharger stop. The BMS knows the route. It calculates the optimal pack temperature for fast charging. It coordinates with the navigation system. By the time you arrive, the pack is at exactly the right temperature. The cheap EV you use to rent doesn't do any of this. You arrive at the charger with a cold battery, and the charging rate is cut in half because the BMS detects the risk. Same chargers, same cars on paper, completely different experience because of software. Chapter 5. The over-the-air update. Here's where the BMS becomes terrifying to traditional automakers. When Tesla pushes a software update to your car, one of the most common things being updated is the BMS firmware. The charging algorithm, the balancing thresholds, the thermal limits, the state of charge estimation model. Your battery is the same physical object the day before and the day after the update, but behaves differently. It might charge slower. It might let you use a few more kilowatt hours. It might predict range better. This means Tesla can extend the life of an entire fleet of batteries with a single software push. They can also, controversially, reduce the maximum charge of an aging battery to prevent failures, a practice that has led to lawsuits. This is why software-defined vehicle is more than marketing. The BMS is genuinely the most important software in your car. It controls the most expensive component, and it can be changed remotely. Chapter 6. Why brands differ so much. If the BMS matters so much, why are some so much better than others? 3 reasons. First, data. A good BMS learns from fleet data. Tesla has billions of miles of real-world battery behavior. Newer EV brands have far less. This is why Tesla packs degrade so predictably, while early production runs from some other brands have unpredictable failures. Second, integration. The BMS works best when it's tightly integrated with the rest of the car. Cooling system, motor controller, navigation, climate. Manufacturers that outsource components to different suppliers struggle to get this integration right. Third, philosophy. Some manufacturers prioritize maximum range from day one and let the battery degrade. Others sacrifice a bit of initial range to extend lifespan dramatically. Tesla and BYD both lean toward longevity. Some others prioritize the spec sheet. When you're shopping for a used EV, the question to ask is not just about the chemistry. It's about how good the BMS is. Unfortunately, this is also the hardest thing to verify. Here's something I want to point out. We talk about EV batteries as if they're the dominant cost and the dominant innovation. They're the dominant cost. But the dominant innovation is increasingly the software. In the last 5 years, the cost of a kilowatt-hour battery has dropped by maybe half. In the same period, BMS sophistication has increased by an order of magnitude. The hardware has gotten cheaper. The software has gotten smarter. This is also why I'm skeptical of new EV brands that focus on hardware specifications. Range, battery size, charging speed peak. These numbers are easy to publish. What's hard is the decade of fleet data and software refinement that makes the BMS actually good. The companies that will dominate the next decade aren't the ones with the biggest batteries. They're the ones with the best BMS. So to recap, the battery management system is the brain of your EV. It monitors every cell dozens of times per second. It balances cells to prevent the weakest one from limiting the pack. It estimates state of charge using sophisticated algorithms. It coordinates the thermal system to keep the pack in its happy zone. It can be updated over the air, changing the behavior of your car without physically touching it. And it's the single biggest reason that two EVs with identical hardware can age completely differently. Next week, we go into something completely different. The inverter, the component that converts DC to AC tens of thousands of times per second, the brain of the powertrain, and one of the most underrated pieces of engineering in modern cars. If you found this useful, subscribe. Drop a comment with what you wish you knew about your EV speed MS. I read all of them. See you Wednesday.